We've now seen how we would implement a method in a class definition. I mean, for the most part, implementing methods is just the same thing as implementing functions. Yes, there's this additional detail about making sure that the class invariant is still satisfied when the method is done, but that's a pretty easy detail to check, and so we're done. That means that we now know how to fully implement a class. So we can now move on and talk about what it means to use a class. So when we're using a class, we have an object for that class, and we're either, say, calling the methods on that object or assigning values to the attributes of that object. So to be a good user of a class, we need to make sure that when we call the methods that we're never going to violate the preconditions of the methods, and that when we assign values to the attributes, we are never assigning values that will violate the invariance of that object. Now, I've trained you all pretty well in this course, so hopefully you all are disciplined enough so that when you use a class, you are all good users that follow those steps. But let's suppose you're at a company and you have this partner. This partner, he taught himself Python online. He has no idea what he's doing, right? He's incredibly sloppy. You want to protect yourself from this person. You want to make sure that if something goes wrong, he gets the blame, not you, because you did everything correctly. What we're talking about here is enforcing preconditions and enforcing invariants. I mean, we've already seen these from the user perspective. So now what we're talking about is how do we write code in our class definition to make sure that we are enforcing these things? Well, let's start with preconditions, because look, we already know how to enforce preconditions because we've already done it with functions. We do it with assert statements, and methods are not any different. Let's go look at a class. So here we have the time class, and let's go look at a method. Our method is the initializer. I have two parameters, well, that matter, hour and minute, and you'll notice that each of those have a precondition, and look at that, I have 4 assert statements that enforce that precondition. If I look at this, I'm checking that hour is an integer, and also that hour is within range. I'm checking that minute is an integer, and also that the minute is within range. Now, I'm not doing anything for self, right? Because we don't have any preconditions for self. Essentially, the invariants right here are the precondition for self, and we're going to assume that those are true. And we're not going to write assert statements for those in these methods. That's not the purpose of that. And indeed, look, this is the initializer. The whole purpose of the initializer is to actually create the attributes. The attributes didn't actually exist before the initializer. And if I look at the preconditions, well, look, the preconditions match up to the invariants. So as long as I enforce the preconditions, I make sure that the preconditions are not violated, well, the invariants are going to follow. And indeed, that's true for any methods, right? It's my responsibility as the definer to make sure that when I'm done, that the invariants are still satisfied. So as long as I enforce the preconditions, because the preconditions are the only way that I can get something from the user in a method call, or at least the parameters are the only way that I can get something from the user in a method call. As long as I enforce the preconditions on that, well, then everything is going to be good. So what's the problem? Well, there is a problem with the invariants. So let's go look at the invariants one more time. And what I'm going to do is I'm going to go over to the terminal. I'm going to import time1, and I'm going to create a time object. I'm going to assign it to t. Let's do 230. So the problem is that, okay, I can protect my methods, but the user is not always going through methods. Sometimes what the user is doing is they're accessing attributes. So I say t.hour, or I can assign t.hour to say 3. Let's go look at this as a string, because that prints it out nice and pretty, and so I see that it's 3:30. There is nothing preventing this Yahoo programmer from changing the hour to Fred. And now we are Fred 30. It's corrupted. Whew. What do we do here? Well, look, the only thing that we can do is to use assert statements to protect methods. We cannot protect attributes directly. Yes, I know that RGB does enforce its attributes, but RGB is a lie. I'm actually lying to you again, and we will see that in another video series. But now I'm not lying to you. The only thing that we can do is protect methods. And so what I'm going to do is I'm going to restrict access to these attributes. I'm going to tell the programmer that the programmer is never allowed to access the hour. Instead, they have to go through some special methods. So let's go look at another version of the time class. And you'll notice I have these special methods called getters and setters, okay? So let's go think about how they work. So I'm going to import time2. And now let's go make a time2 version of a time. Let's go assign this equal to s. And so the idea here is that if I want to change the hour, I am not allowed to write this. Instead, I'm only allowed to write set hour, like this. If I look at this, I see that it's currently 4:30. And the reason why this is helpful is because if I set this to Fred, look at that. Because look, the setter, well, it has a precondition, and this precondition is going to match the invariant. That is not a coincidence, right? The entire purpose of the setter is to set an attribute which has an invariant. And because there's a precondition, well, now I'm going to write assert statements that actually enforce my precondition. So now, since you're using the setter and not the assignment statement, well, okay, now I'm protected. Okay, so that makes sense, right? The whole purpose of the setter is to prevent you from changing an attribute in a way that you're not allowed. But what about the getter? I mean, because look, the getter only has this parameter self, and we don't enforce any preconditions on self. And in fact, there aren't any assert statements here at all. Yes, but look, I mean, the minute that I start saying you can do s.hour, well, now you're going to get into bad habits and you're going to start assigning it. So look, if I'm not going to allow you to access hour directly, I'm not going to allow you to access hour directly. So if you want to look at it, you're going to need to use the getter instead. So the whole point, one way you can think of it is the purpose of the getter is meant to prevent accidental changes to the variables. Okay, so this makes sense, right? The idea is that I have these getters and these setters, and they are going to protect my attributes. And that's where we're going to put our assert statements in order to enforce our invariants. But the attribute is still there. I mean, look at that. I mean, it's still in the specification. So the programmer could just tell me to go to hell and could still change it and do that. So how do I prevent that? Well, that is an interesting question, and we will address that in the next video.